Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 5, Solving Equations with Radicals. Classwork, Example 1. X cubed plus 9x equals 1/2 times the quantity 18x plus 54. Okay, at first this may look a little confusing and challenging, but if you just focus on portions of it at a time, if I look on the left, I have an x to the third power and I have an x to the first power. There's nothing I can do here. I could factor out an x, but I don't want to do that yet. I'm just going to leave that alone and see what happens with simplifying the right. I have a half times a quantity, that is the distributive property. 1/2 of 18x is 9x. 1/2 of 54 is 27. Okay, when I'm solving for radicals, if I notice my linear terms are equivalent on each side, and I move all my x's to one side, that's our goal, to get all the x's on one side and all the numbers on the right. And that will leave me with x cubed. My linear terms cancel. 9x minus 9x is 0, and I get x cubed equals 27. When I have just a variable by itself on the left and a number on the right, I'm almost done. All I have to do now is the inverse of cubing, which is the cube root. So if I take the cube root of both sides, I get x equals the cube root of 27 is 3, and my answer is 3, and we should always check. So I'm going to substitute in 3 for every x. So it would be 3 cubed plus 9 times 3 equals 1/2 18 times 3 plus 54. And when I simplify this, 3 times 3 is 9 times 3 is 27, plus 9 times 3, which is 27, equals 1/2 18 times 3 is 8 times 3 is 24, carry the 2, 3 times 1 plus 2 is 5. 18 times 3 is 54, bring down this 54, and continue. 27 plus 27 is 54. 54 plus 54 is 108, and 1/2 of 54. Try that again. Wow, why am I writing 55? 54 equals 1/2 of 108 is 54, and that checks. Number 2. Okay, look at it. I have an x on the right, I have x's on the left. The right, I can't simplify it this time. There is a linear term, there is a constant, nothing to combine, but here I have the distributive property. X times x is x squared. X times a negative 3 is negative 3x minus 51. Okay, I want to get all of my x's on one side, so I'm going to add 3x to both sides. X squared. My linear term cancels. These cancel, and I get 13. I want to move all my constants over to the other side, away from the x. Add 51 to both sides, and I get x squared equals 64. Almost done. I don't want x squared, I want to know what x is. The inverse of squaring is square root, so I take the square root of both sides. The square root of x squared is x, the square root of 64 is plus or minus 8. I now want to check both. Substituting in positive 8 to this, I get 8 times 8 minus 3 minus 51 equals negative 3 times 8 plus 13. Simplify. 8 minus 3 minus 51 equals negative times a positive, negative 24 plus 13. 5 times 8 is 40, minus 51 equals negative 24 plus 13, which is a negative 11. And 40 minus 51 is negative 11. There it checks. Now I'm going to check the negative 8. Negative 8 times negative 8 minus 3 minus 51 equals negative 3 times a negative 8 plus 13. Simplify. Negative 8 minus 3 is negative 11. Negative times a negative is positive, 24. Negative times a negative is positive, 88. 24 plus 13, 88 minus 51, and it checks. Okay, exercises. Find the positive value of x. That makes each equation true. And then verify your solution is correct. This is an exercise. Pause the video. See if you can do it. Unpause the video. Check your answer to mine. Part A. Solve x squared minus 14 equals 5x plus 67 minus 5x. First thing I'm going to do is simplify each side. Nothing I can do on the left. 5x minus 5x cancel, leaving me with 67. Move my constants over to one side, leaving me with x squared equals 7 plus 4 is 11, carry the 1, 81. The square root of both sides, because I have a squared here, the inverse of squaring is square root, and that will give me x equals, and the answer is plus or minus 9. Now it did say just find the positive value of x, but there's a positive and a negative value. I will only check the positive from now on. So plugging in the 9, I get 9 squared minus 14 equals 5 times 9 plus 67 minus 5 times 9. 81 minus 14 equals 9 times 5 is 45 plus 67 minus 9 times 5, 45. 81 minus 14 is 67. 45 plus 67. I know 45 minus 45 will cancel. I'm just doing PEMDAS, order of operations. When we're down to addition and subtraction, we work left to right. 45 plus 67 is 112 minus 45. And 112 minus 45 is 67. It says to explain how you solve the equation. Okay, so here's a written solution. To solve the equation, I had to first use the properties of equality to transform the equation into the form of x squared minus equals 81. More specifically, I combined like terms on the right, getting 67, and then I used the additive property of equality, so I added both 14 to both sides to get x squared equals 81. Then I had to take the square root of both sides of the equation to determine that x equals 9, since the number x is being squared. So the answer was 9 and negative 9, actually. But they're only asking for positive solutions. Number 2. Okay, let's use blue this time. Solve and simplify this. Nothing I can do on the right, but there's the distributive property here. I get x squared minus x times negative 1 is x equals 121 minus x. Okay, I want to get all my x's on the left in this case. The linear terms are opposite, so they cancel, and I get 121, and these cancel. Since x is being squared, the inverse of squaring is the square root. The square root of x squared is x. The square root of 121 is 11. The answer would be positive and negative 11. I will just check positive 11. 11 times 11 minus 1 equals 121 minus x. 11 times 10 equals 110. 121 minus 11. 11 times 10 is 110, and sure enough, they're equal. Number 3. A square has side lengths of 3x inches and an area of 324 inches squared. What is the value of x? So what they're saying is, let's make this nice and neat. And wow, beautiful. Try that again. Alrighty. My magic pen is not working. Oh, there we go. That's better. Alright, finally. Okay, so we have a square. A square has a side length of 3x. So all sides are 3x, 3x, 3x. And an area of 324 inches squared. What is the value of x? Well, area equals length times width. The area is given as 324. So we always write a formula, substitute in the givens, simplify, and solve. The length of the square is 3x. Therefore, so is the width. And actually, what I also could have done was say area equals side squared. That's another way to write this, and let's use that. So since I'm going to use side squared instead, that's the area of a square. A square is a rectangle, but I can also use s squared, then it would look like this. So then 324 equals, remember to distribute your 2, 3 squared is 9, x squared is simply x squared. So getting rid of the parentheses by distributing the power. And then I want to get x squared by itself, so I divide by the coefficient 9. And I'm left with x squared equals, 9 divided by 9 is 1. 9 goes into 32 3 times, 27 with a remainder of 5. 9 goes into 54 6 times. The square root of x squared is x. The square root of 36 is 6, positive or negative. And I'm only going to check the positive one because distance cannot be negative, so I would ignore the negative anyway because that's called an extraneous solution when it does not make sense in the context of the problem. Now I'm going to solve. 324 should equal 3 times my x squared. So 324 should equal 3 times 36. Is that right? No, my parentheses in the wrong place. Let's write it down correctly right here. 324 equals 3 times 6 squared. Notice how parentheses matter. 324 equals, do inside the parentheses first, 18 squared. And 324 equals, hey Siri, what's 18 squared?
18 raised to the second power is 324.
And there you have it. Okay, number 4. I have a x to the third, I have a constant, and I just have a number constant by itself over here. Get all the numbers to the right. So I'm going to subtract 14 from both sides. 3x cubed negative 3x to the third. Constants cancel. Negative 67 minus 14 is negative 81. Divide both sides by the coefficient, negative 3. Negative divided by negative is positive 1. X cubed equals negative divided by a negative is positive. 81 divided by 3 is 27. To get rid of an x cubed, we take the cube root of both sides. Don't forget to write your index there. And we get x equals 3. Check my answer. Negative 3 times 3 cubed plus 14 should equal negative 67. Negative 3, 3 cubed is 27, plus 14 equals negative 67. 7 times 3 is 21, carry the 2. 3 times 2 is 6, plus 2 is 8. Negative times a positive, plus 14. Negative 81 plus 14 is negative 67. And they check. Number 5. Okay, simplifying the left, I'm going to distribute x squared plus x times 4, 4x. The minus 3 is tagging along. 4 times x, 4x. 4 times 19.5. 19.5 times 2 is 39. 39 and 39 is 78. Move all of your x's to the one side. And I get x squared. 4x minus 4x cancel. Minus 3 equals cancel. 78. Add 3. Add 3. X squared equals 81. Inverse of squaring is square root. Square root of x squared is x. Square root of 81 is plus or minus 9. I will check the positive 9 only. 9 plus 4 minus 3 equals 4 times the quantity x, which is 9, plus 19.5. 9 times 9 plus 4 is 13, minus 3 equals 4 times 28.5. And then 9 times 10 should equal, is that right? Just checking here. 9 plus 4. No. I do not want this parentheses here. Of course, this is all combined. So let me just erase this here. I did not want that parentheses there. That throws everything off. So in checking this, I'm going to get 9 plus 4, which is 13. And that is not in a parentheses. See what I mean? So if it's not in the parentheses, we're going to do it in a different order. So it's not this, it's 9 times 13, which is 117 minus 3, which is 114. 28.5 times 2 is 57. 57 and 57 is 114. So they check. Number 6. 216 plus x. Nothing I can do on the left, so I'm just going to bring it down. You like my green pen? Click on green, right, and it's still black. Anyway. X times x squared is x cubed. X times a negative 5 is negative 5x plus 6. Still can't do anything on the left. I want to clean up the right. Actually, no, that's not right. I have a polynomial over here with a degree 3, degree 1, degree 0. No like terms. I want to get all my x's to one side. So I bring down my 216. My x cubed is here. Negative 5x minus x is negative 6x plus 6. Oh, I forgot my x here. Disregard. Holy cow. Sloppy today. All right. I have minus 5x plus 6x on the right, combining like terms. 216 plus x equals x cubed plus x. That's better. Now I move my x's to the other side, and I get 216 equals x cubed. The inverse of cubing is cube rooting. Don't forget your index when you write the radical. The cube root of 216. I will do this with a factor tree. 2 times 108. If you haven't seen my prior videos or been in my class, this is how we do it. Half of 108 is 54. Half of 54 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. So I'm left with 3 2's and 3 3's. So when we have 3 2's under a radical, that's the same as 2 cubed. So that would be rewritten as the cube root of 8. 2 times 2 is 4 times 2 is 8 times the cubed root of 3 times 3 times 3, which is 27. Well, when we have 3 numbers underneath a radical, then it becomes 1 outside. That's how I teach it to my students. So the cube root of 8 is 2, and the cube root of 27 is 3. And these obviously will equal x. So therefore the answer is 6. X equals 6. Okay, so now I check that. Where can I do it where I have room? 216. So I'm just rewriting this right here. Plus my x equals x times x squared minus 5 plus 6 times my x. 2 times 6 is 12 plus 6 equals, oh, that's 216. Silly me. That's 216 plus 6 is 222 equals, this should be a 6. 6 times 36 minus 5 plus 36. So 222 equals 6 times 31 plus 36. 222 equals 6 times 1, 6 times 3 plus 36. So 222 equals 6 plus 6 is 12, carry the 1, 8 plus 3 is 11, plus 1 is 12, carry the 1, and sure enough, it checks. Number 7, what are we trying to determine in the diagram below? Okay, so I have an 11 inches squared on this side, 5 inches on this side, and 4 square root x inches on this side. We don't like unknowns, so we want to find x. So what are we trying to determine in the diagram below? What should be under the radical to make this true? It is a right triangle, which means we use a Pythagorean theorem. So determine the value of x and check your answer. So my rule is, step 1, write a formula. Pythagorean theorem, a squared plus b squared equals c squared, where c is the hypotenuse. This can be a and this can be b, or this can be a and this can be b. That does not matter. What really matters is that c is across from your right angle, the hypotenuse. A squared, 5 squared, plus b squared, 4 square root x squared, equals c squared, 11 squared. Write a formula. Substitute the givens, simplify and solve. 5 squared. Distribute your power. 16. The square root of x squared is x, equals 121. Get x by itself by moving everything away from it. Subtract 25 from both sides, and I get 16x equals 96. Divide by 16, divide by 16, and x equals 6. Check to see if it's true. A squared plus b squared my b is 4 square root x. I'm just going to change that to 4 square root 6 squared equals c squared. 25 plus 16 times 6 equals 121. 25 plus 96 equals 121. 121 equals 121. Check. So 4 square root 6 is the only value of x that will make this problem true. Remember, I can't use a negative here because then that would be a negative distance, and distance cannot be negative. That is the end of lesson 5. Review the lesson summary and go to your problem set.